Okay, are we going? Think so. Hello. I'm just setting a couple things up. Hey, how's it going? Hello, hello. Welcome everybody. Good morning for me. Good evening to probably most of you. um, Actually, probably half of you. Good evening to half of you. Good morning to me and the other half. Hello. How's it going? Pretty good. Yeah, not bad, I guess. Nothing super interesting going on today. So I'm in my last term of school, and the term hasn't really picked up yet. So I don't uh, I don't really need to do any school stuff right now, and I love going live on YouTube. So I think right now is probably a good time. How are the rest of you doing? How's everybody doing? Feel free to ask any question you want, everybody. Perfect. Thanks for starting me off. Hey, could you tell me the math required for data science and where to learn them? Yeah. There's obviously a lot of math in data science, especially if you're assuming the stuff on the board. So right now I have analytics, data science, machine learning, deep learning, like they're separated topics. They're not really. To learn data science, I'd say you should learn analytics, machine learning, and deep learning. Uh, and if you want, so to be honest, there is a lot of math under it, and whether you should learn it or not is a question that I can help you answer. But the math that is definitely involved, if you were to go down a theoretical route and to understand every piece, is definitely the first three calculus courses that you would take in a university, which generally the first one is differential. So like derivatives basically with single variables. Some of you may have done that in high school as well. Probably, actually, you do. Yeah, normally you do that in high school. And the second course is integrals, which that one some of you may have seen in high school, but for me it was a university topic. And the third course is where it gets really, really important, and it's really just an extension on all of the stuff that you've already seen in the first two courses, except that's multivariable calculus, and so it's taking derivatives for multiple variables, which is really about that's actually pretty much all of what deep learning is defining some function and then in a clever way taking the derivative of an error function, and that way you can minimize that, and you're just trying to minimize the error. So it's mostly calculus under the hood, but as well as all the different models that can be created is generally seen as a statistics thing because it's a stochastic or random thing. Stochastic just means random. So there's a fair amount of statistics in there as well, which there's a lot of different ways to learn that stuff. Generally, statistics books are actually pretty good to just pick up regardless of your background. Some of the more heavy stuff, like the deep learning book, for example, is really heavy, and you have to know the third main idea, which is linear algebra, which is essentially again just multiple variables, um, and doing stuff like matrix multiplication, matrix vector multiplication. That stuff is you should know all of that if you want to fully understand the data science ecosystem. But to just understand something like analytics, yeah, basics which can get me going is fine, and I don't want to go in depth, and that's totally fine. And so to the basics to get going are, I would say, definitely understand how to take the derivative of a function. You probably don't need to understand integrals at all, which is just the reverse direction. The simple linear algebra stuff And simple meaning the operations themselves, understanding what they do and why we might want them, and not all of the math and stuff behind it. So again, matrix vector multiplication, which really just means doing stuff at the same time. It means getting multiple answers at the same time, because we have a lot of information in something like a neural network. It has a lot of different variables going on. So matrix vector multiplication, matrix matrix multiplication, and just what vectors in matrices are, along with taking the derivative of a cost function, will go get you a long way. And really, how I'd suggest to learn all of this stuff is to take the Andrew Ng machine learning course. It's pretty much covered in the Andrew Ng deep learning specialization as well, but I would definitely take the machine learning course first. And it's going to teach all of that stuff, assuming really no background. It's easier if you have taken it in university already, but it's aimed at people that have not taken it in university at all. So Andrew Ng machine learning course is my recommendation for that. Hello, is there any study partner app or thing to share study time specifically for data science? Not that I'm aware of. I don't really know. There's a Discord group that I have in particular. If you go to the About section on my YouTube, maybe you can find a friend in there for study time together. Recommended certifications for getting a job: Azure, data analytics, IBM. So yeah, any of the cloud stuff is really good. Azure is obviously the Microsoft one, and if you're trying to get a job at Microsoft, then Azure is definitely the one to take, as well as it's not a bad one to take no matter where you're going. I'd personally probably push a little bit more towards AWS or even GCP, the Google one, instead of Azure, just because I think it's maybe a little bit more common, but also, I don't know, really take your pick on that one. Any cloud certification would be very beneficial for sure. The IBM data science certificate is very helpful, but I don't think it's all encompassing. It's definitely missing the deep learning component, and you really should learn deep learning if you are trying to become a data scientist. So if you did say data analyst, and so becoming a data analyst is a little bit easier. You can do the IBM course, maybe the Google course, and some statistics chops probably could take you a long way, as long as you've got the technical background like SQL. So really know your SQL stuff for data analytics. And even something like Excel is actually not a terrible idea, to be honest. Even though it's not really my favorite thing, it still can be quite useful. Hello, I know the basics of statistics, good, but I am a newbie to data science. No, you're not. If you know the basics of statistics, that's pretty good. Could you please guide me where to start from, and will I be able to complete the basics in 1 month in order to do some projects? I mean, you can complete the basics in a day or 2 days or a week or a month or however long you want to spend on it. But I don't think it'll sink in properly and have learned enough in less than a month. That would be pretty impressive, to be honest. You could learn a lot of stuff in a month, though, for sure. I just like to, I have a tough time answering the time-based questions, and it's not because I don't know, it's because everybody is different, and I don't want to put some false constraint on you where it's like, yes, you should be able to learn all of this in a month, and if you don't, or if you feel unsteady about that, then it throws everything off, and that's not what you want at all. But you can learn a heck of a lot in a month, and you can do some projects at any point. Like you can, it's really just to do some projects. It's the level of hand holding, basically, that you want to do. So you can hold my hand or someone's hand and copy code and just follow what they're doing very, very closely at any point, even without even understanding the code, basically. But you want to step further and further away from the hand holding and be able to not just do everything with your eyes closed and without using the internet, but at least without, actually following someone's project, and more about, okay, I need to do this. Let me look up the documentation for this library, or I need a library to do this. So you can do whatever you want at any stage, but just keep progressing further and further towards doing stuff by yourself is the main idea, and to actually get the attention of employers. Yeah, to be honest, you're probably never going to impress them by showing you can classify the MNIST handwritten digits or doing advanced regression on California housing. That stuff is phenomenal for learning. Go ahead and do PCA and other dimensionality reduction and convolutional nets and neural networks themselves, as well as all the scikit-learn models. You can learn, you know, k-nearest neighbors, linear regression, ridge and lasso regression, you know, random forests, the boosting models. So you could do all of that stuff in the simple projects, but you want to progressively move towards you know, just doing stuff by yourself and more complicated things that would impress an employer if you're trying to do that. Could you share some resource so I can revisit those stuff? To answer that question, I thought that that was the answer to that was the machine learning course by Andrew Ng, but can you ask again in particular what resource you're looking for? Matplotlib or Seaborn or Plotly, what is the best? So Matplotlib is the most convenient most of the time, given that you know you just import matplotlib.plt or whatever it is, and then you just plot like an image or a scatter plot or whatever very quickly, and it's awesome. For actually doing data visualization, I think personally that Plotly is the best. Seaborn, to be honest, I'm not incredibly familiar with. I feel like it was slightly, it's not out of date by any means, but I just haven't found a need for another visualization library at all. So I can't speak to Seaborn too much. But Plotly, you can do phenomenal things very easily. It is just, in my opinion, slightly harder to remember some of the simple syntax because honestly, people make a big deal out of visualization, as you should be, because there's a lot of different crazy techniques you can do to properly convey and tell a story. But to be honest, most of the time, when you need to do like a visualization, it's actually just a simple scatter plot of two variables or a histogram of one variable, or very basic stuff that you can go ahead and do in Matplotlib because it's almost certainly installed in Google Colab or whatever environment you're using, or it's very lightweight and easy to set up. And the syntax is just incredibly easy to remember, like plt.scatter, you know, xy or whatever. It's very nice. So. That's my opinion on the visualization libraries. For those of you joining, if you wouldn't mind just asking a question or two so I can have a queue to go through, I'd really appreciate it. And also, if you wouldn't mind dropping a like on this stream, it's really beneficial for me. I would appreciate that a lot. For maths revision of topics such as linear algebra, basic calculus, stats, and probability. Yeah, okay, so that's why I did suggest the Andrew Ng machine learning course for you because they cover all of that stuff in the way that you wanted it. Because he said basics to get going. He teaches the basics to get going in that course. If you have trouble finding that course, let me know. But a simple search for the Coursera machine learning course by Andrew Ng should pop up very easily. So let me know, but that should be fine. And it's totally free. It's just videos to watch for free. So I would recommend that. You're very welcome. And yeah, I'm at the bottom here, so make sure you ask some questions. I'd really appreciate that. Do deep learning use? Okay, I assume you accidentally hit enter. Yeah, that's okay. I'll wait a moment for that. And thanks a bunch for you guys who dropped a like on that. I really appreciate it. It helps a lot. You're very welcome. No problem at all. Hello, welcome to the new people that just popped in. How's it going? How are you doing today? Okay, again, thanks for the likes you just dropped. I really appreciate that. Helps a lot. 6 likes. Thanks so much. I appreciate that. Yeah, you're very welcome. So found your channel yesterday only and enjoying watching. So what video did you find me by, or did you find me through Facebook, through posting a video on Facebook, or just through YouTube naturally? Have you ever worked with people and HR? Okay. Have I ever worked with people and HR data? Do you find interesting? Okay, so it's kind of tough to avoid people, and it's interesting because I know there is like actual jobs in this thing called like people analytics, which I think is almost a little bit silly of a term, but it makes sense that you know we have a lot of different information, and there's a lot of different approaches that you can take to analyze people, and I'm not just talking about like look at their eye color or whatever about that. It's generally about like in a company we have many different types of people. Of course, the simple categories you can do are just people that work within the company, and people we're trying to get on board, not on board to join the company, but to buy our product, use our service, or whatever. And there's a lot of different things that you can do to try and figure out what this person is doing, and kind of how they relate to our system to make the best approach to either keep them going. So if we think that they've been using our system for a long time, but we think that maybe they might be leaving, then we might perform analytics automatically to send these groups of people an email to be like, hey, we're offering you like a 50% discount because you've been a really loyal customer and we want to keep you going. Or maybe we figured out that these groups of people are just they're not really using our product, and we're just gonna maybe send them something simple, be like, hey, we'll give you 10% to keep going, or just go on your way. That's totally fine. And there's a lot of different stuff like that that you can use. I think that the general term here is just like customer segmentation, which can be done through something like clustering, or it also has a lot of interaction with like recommendation systems. Who is this user? What do we know about them? And what information should we show to them? Like if we're Amazon recommending similar products that they've looked at in the past, or we think they might like for whatever reason. That's Amazon did that very early, and it's done extremely well for them, and they continue to improve that every day. So a lot of different stuff for sure. Would it be better to do a master's in statistics rather than a master's in data science? So I like this question because it's basically the term of whatever a master's is. So master's of AI, masters of statistics, masters of data science, masters of machine learning, deep learning, all these different terms, they really don't mean much. And what I mean by that is most employers don't actually care what it says. No, it's very few people are going to be like, oh, your master says artificial intelligence, but yours says data science. I look down upon that because it's not as fancy a term. Most people actually don't care. What they do care about, and what you should care about, is what you're going to be doing there, and the people that you're going to be interacting with. Because if you are with a professor that if they're mentoring you but also really don't care what you're doing, and you're not helping them towards some interesting project, then it's not going to be an amazing experience, and you're not going to learn a lot. But in a master's, it is a really good opportunity to meet with someone regularly, become pretty much really good friends with a very intelligent person, most likely, and to do some very exciting work, and hopefully just improve your portfolio in general. So it's really not about the particular name of the master's. It sort of is about the school, to be honest. I mean, obviously, you do want to go into something more prestigious than some lesser known schools. I think that's probably, that goes without saying. But the actual term is, not super important in my opinion. It's about what you do and what you want to do. Also, another interesting point about that is some of them can be incredibly theoretical, and some masters can be very practical, or some mixture of the two. And you need to figure out what it is that you want to do. For many people, I suspect the majority of people that would be listening to this, they don't care a ton about mastering the theory, but want to, get a master's degree to, maybe move into, Canada or United States or another country, or in general just to improve your portfolio and to get jobs. And so you would probably want to make sure that what you're doing is pretty practical, and you're going to be coding in common languages like Python, or like PyTorch or TensorFlow or something like that. And not like this, really unknown thing that is for this very particular niche, unless you want to go down that niche, like healthcare, if they use a particular language in healthcare or whatever it is like that. But it's mostly about the experience, how hands-on it is, what you want to do, versus, just some arbitrary word that's thrown around like analytics or data science. I hope that was helpful. Found you via LinkedIn. Awesome. That's great. Is deep learning used instead of machine learning all the time, since it seems to have better performance than ML. So yes and no. Deep learning is incredibly powerful, and for many concepts, and basically it's up to the problem and also the people solving the problem on what they think it's best to try. And so if you're hit with a problem where you are trying to diagnose what's in a picture, everybody is going to, everybody that's worked there for a while will say, yeah, we want to use a convolutional type neural network or maybe some sort of vision transformer, which are still neural networks basically. It's very rare that if you see something like that, people would be suggesting like a random forest or k-nearest neighbors type stuff like that actually has a fair amount of applications. But in terms of like the random forest or boosting models and stuff like that, they are generally used when the data is just something like that looks more like the California housing data set, if you're familiar with that, which just has numbers, and you're not quite sure what the interactions are with each of the other variables, which variables to use. Something like a random forest or k-nearest neighbors, or even maybe a linear regression, is actually could be much more powerful than something like a heavy neural network. You'll just find that random forests in particular are actually really good at solving problems kind of like that. It's just a bunch of numbers or maybe one hot variables. And neural networks, they're so powerful that sometimes it can be trickier to work with them than just to tune some variables on a random forest instead. So not always, but there's particular niches like language, like vision, and more really modern stuff that neural networks are really the go-to. But it's not that deep learning has just kind of taken over the field of machine learning, and it's not important to learn what a random forest is and stuff like that. But one thing for sure is that it's not incredibly difficult. If you've seen the scikit-learn documentation stuff or any of my projects where I go through the scikit-learn projects, you'll see it is incredibly easy to make a random forest, where it is not incredibly easy to make a neural network that solves the problem. And it's not that neural networks are bad, it's just that they are an extra step of complexity where it takes some understanding of the building blocks, like, okay, I need to do this. Like if it's a picture, I need to get the input, and then maybe do I want to do transfer learning on a convolutional net, and then maybe do I want to cut this off halfway and make my own kind of model at the end. I'm getting into some pretty complex stuff. Basically, the idea is that if the data is just like a simple row, like in a table, which is incredibly common in companies and just SQL tables, you'll see a lot of those are the types of columns, just like these numbers or one hot variables or whatever. Then random forests are a really good thing to try. Boosting models are a really good thing to try, and regressions and just kind of averaging type techniques are really good baseline models. But deep learning is not trumped machine learning. It just has in particular niches, and it's great to learn it because it may solve pretty much every problem. Hey, I found your channel in YouTube algorithm. Perfect. Love to hear it. I've started to learn PySpark. Yes, I love PySpark. And my tutorial was amazing. That's really great to hear. Literally the best I could find on the platform. Yeah, that video is doing extremely well. It gets several hundred views every single day, which is very good. So I'm glad to hear that. I should make more stuff like that. 2 in the morning here. 2 in the morning here. Okay, greetings from Australia. Oh, that's wonderful. Hello, Australia. Definitely on my to-do list to go for sure. You're very welcome. Has this pandemic affected jobs in data science? Yeah, positively. To be honest, yeah, programming jobs have not taken a hit negatively for the most part, unless they are companies that really relied on some niches. Not niches, but obviously some companies are much more focused on communication in person and moving around stuff. Like, obviously Amazon had both mostly positive rewards from it, but negative ones as well, because they do actually have a lot of in-person interaction. Like they're aside from AWS, their whole company relies on, people working together to package stuff very quickly. And yeah, that had some problems with COVID-19 for sure. But for the most part, many programming jobs just kind of opened up because more people are moving online. We got more comfortable with remote working, and it's really going to change the world for, in my opinion, not, I don't think the pandemic has been positive by any means, but I think it has definitely opened up the world positively to a number of things like remote working, because it's, it does really take a toll on some people to, wake up at like 5 in the morning, drive 2 hours to work, maybe be on the train bunched up with a bunch of other people, just to do a job that they really could do while lying in bed, and probably do a much better job while watching their children, making proper meals, and not just going to, eating out at lunch or whatever every day. And so a lot of positives, obviously a lot of negatives, but it has changed the world for sure. Hi, Arshia. Hello. How's it going? Um, Please upload some hands-on examples of PySpark projects covering exploratory data analysis and neural network deployment. Yeah, so actually I forgot which project it is. Maybe you can scroll through my projects quickly, in the Python projects list. I know at least one of them uses PySpark. Yeah, I should make more that actually use PySpark for sure. You're right. At work, support SVC support. I was about to say support vector machine, but support vector classifier. Is that what that is? And LG, I don't know what LG is most of the time better than RNN LSTM. Okay, so you're talking about time series stuff. I don't think I know what those acronyms are. Is there any good habit you do when studying or work as a data scientist? Really, you just have to, really like what you do, and if you don't like it, then stuff's going to be tricky. And honestly, at the beginning, everything is always a little bit negative, seeming like it's just very difficult to get going on stuff. But you can really get into a rhythm with data science and machine learning, where once you feel like you've got, you know what each of these terms are, and you have a good understanding of each of those in the math, as well as in understanding on how to code them very easily, you get into a rhythm where it feels fine. And so there's not really a study pattern that you would need per se. You don't really need to, I'm not going to suggest something like, have a good meal in the morning or whatever it is like that. Do whatever it is that makes you happy, and just enjoy learning data science. I think it's super wonderful, and it'll be a good experience, I hope. I'm just going to look at my phone for a brief second. And okay, so what do we got? Any project coming up related to anomaly detection? No, anomaly detection is something um, I should really learn more about. To be honest, I know what it is and I know the basic techniques. That and recommendation systems for me is on my YouTube/learning to-do list. I downloaded the book last night on recommendation systems. I plan on reading that. And anomaly detection is something I'm not overly passionate about, and so that's probably why I haven't made a video on that at all. Recommendation systems I will for sure, though. Do come to India. I probably will come to India at some point. How to select a set of models to compare to choose for a particular problem. So basically, to choose between models, what you would do is, so the normal split of a machine learning model data set is you have one big chunk of data, so several rows of information, and then you partition it into, say, 80% for one set, 10% for another set, and 10% for another a different set. And we call the 80% piece the training set. So you train the model on that. You get a validation set, which is 10% of information, or 10% of the data, and then you have this holdout set or test data set. We keep that until the very end. So forget that exists. And we have 10% of the data for that. You pick a bunch of models. So a k-nearest neighbors model, support vector machine, random forest, boosting model, simple neural network, complex neural network, convolutional neural network, whatever. We get a bunch of models, and you keep training on the training set, and then you evaluate its performance on the validation set. So you train on the big set, and then you say, okay, how well does this model do on this validation set, this 10% split of data? And then you can compare all these different models, while not just the general architecture, but as well as playing around with all the parameters, like the number of nodes in a neural network, the regularization on a neural network, the way you're encoding variables, so standardization versus normalization, one-hot encoding or embeddings, and all these different techniques that you can play around to get the model that you're happy with, and you keep evaluating each of those different models on the validation set. You pick the model that has the lowest error on the validation set. So this is some sort of error. You'd be looking at some sort of error function, like the mean squared error, which is just the higher the value is, the worse you're doing for a regression problem, which means predicting continuous values. Or you're looking at some sort of cross entropy, which is again just some positive error function, which can measure your error for like a classification model. And so you look at all those different errors, you compare those models on the validation set, you pick the best one, and then because that's if you're trying to tell your boss or whatever, give an optimistic way of saying, oh, this has 95% accuracy, or oh, on average we're going to be off by the value 20 or whatever, then that's overly optimistic to have picked between 50 different models and then chosen the best one, and then to report back that same error that you got. That's why we have that holdout set of data, why we whatever model you picked, we just run its error on that test set. Almost certainly the error on that final set is going to be a lot higher than it is on the error on the validation set, because it hasn't seen it at all, and you've just you picked between all the different models. Okay, so yeah, so hopefully red one. I was hoping you got a chance to explain those acronyms, but that's okay. Okay, what do you think about using Kivy? Right. Kivy and Beware framework for data analysis on Android is a good idea. So I hit this about a year and a half ago. I found the Kivy project, and I was super excited by it because I also didn't want to go through. I also wanted to use Python for the Android UI setup and all of that. I found that it just wasn't. It wasn't what's the term? Mature enough. It wasn't mature enough at the time for me to use it. Maybe that's changed in the last year and a half or so, but I would like to revisit that again. What do I think about graph-based machine learning? It's on my to-do list. It's honestly something that it's a very modern technique, and I don't know too much about graph-based machine learning. How about data efficient machine learning? Yeah, I mean, not much to say about the last piece. Graph-based machine learning is something that I know I should learn. I know everyone here should learn, but it is a complicated technique, and it's on my to-do list. I just started learning Python for data science. Should I focus on data structures and algorithms? Can I do that later? So what are you trying to accomplish, basically? So you started learning Python. So if you're a relatively beginner in programming, then that's totally okay. Should you focus on data structures and algorithms, or can you do that later? It really is up to what you think is exciting for you. So if you think it's interesting to learn about, what dictionaries are, why they're fast, why they're better than lists at some particular things, stuff like graphs. We just ran into graphs, but that's graph-based machine learning is different than just actually using graphs, although it's the same idea. But if you're excited by learning data structures and algorithms, then I would recommend that you do that. Or if you're trying to get a pretty good job, then you probably should get pretty good at that stuff no matter what. But honestly, it is actually something that would be very beneficial for everybody, is to learn dictionaries, lists, sets, just hash tables, which are really what dictionaries are, and graphs, and maybe not necessarily into the really heavy duty stuff quite yet, like dynamic programming, or breadth first, depth first search, all that graph stuff. You might not necessarily need to go into that level, but at least the data structures to get comfortable with Python in general, I think is very beneficial. Okay, I have 2 years of development experience in banking domain. My question is, while learning data science, should I target only those banking sector projects, or I will explore better in others domains? I, Whatever you want to accomplish, if you're trying to, become a data scientist, then I do. Actually, it's really up to you. It's great if you love something in particular, like banking, and there's many jobs in that, especially in data science. Feel free to go into that niche and stay in that niche as long as you want. But if you are looking to kind of branch out and become a data scientist, and you're able to join whatever company you want, because you learn the generic skills, then yeah, I'd probably branch out from your niche a little bit. But it is up to you. You would probably do just fine in the banking niche in particular. It's always good to be specialized as well. It doesn't hurt. Which activation function is best for time series models? Probably still ReLU in the most of the nodes. It depends on what on your output. It depends, but in the middle, most of it's ReLU is probably just fine. I have time-stamped data of sugarcane fields and their yields. Ooh, that rhymed. Fields and yields. After harvesting, how can I train a model to forecast yield? Okay, so to train a model to forecast yield, you should see, if you want to do it in a deep learning based approach, then you should check out I have 2 big videos in my Python projects, the LSTM which is just single variable, and then the other one is multivariate time series forecasting with LSTMs, and as well as CNNs. Both are commonly used. CNNs are probably, at least 1D CNNs are probably a little bit lighter than the LSTM, and there's also GRUs, which are basically LSTMs but a little bit lighter. All those different models will be useful to you, and I explain them fully for mostly beginners in those 2 videos. So I would go to my Python projects, and the LSTM ones should explain how you can do that. Okay, perfect. I am at the end of the questions here. If you guys have any more questions, then I would love it if you went ahead and asked those, and I will just be 30 seconds here, but I'm still reading over there. Don't worry. Ask some questions. Come on. Don't be shy. Ask some questions. Who's being silly? Come on. People are being shy. No need for that. You watch those 2 videos, but I'm unable to get anything from that about my. Really? Okay, so I don't see what the problem is. Let me try reading that again. I have time-stamped data of sugarcane fields and their yields after harvesting. How can I train them up? I don't know. Sorry. Did you understand those 2 videos? Because those videos aren't going to cover sugarcane yields, but they should cover, if you have time stamped, so you know the order of this data, and you have numbers to predict over time, then you should be able to adapt those models and those techniques of building the functions to generate the time series format that's useful for these neural networks. Then you should be able to take that and convert that to your problem. I don't quite see what the issue is. Maybe watch it again and really focus on thinking about it from a general point of view versus just watching it to exactly understand the particular problem that I'm trying to solve, because it's a general thing, right? We're trying to forecast and predict variables over time. Unless you're saying how can you predict further in the future, which I don't think I covered. You would do that through just basically iteratively feeding the output back into the input of the model. But yeah, it should teach you how to do time series forecasting. What is the project you had the most impact at work? So I don't really want to go into the specifics too much. I did a lot of interesting stuff at my last company at Deep Breathe. We did some really interesting lung ultrasound automation. I can't, we don't have a published paper on that quite yet, so I don't want to talk about it too much. But that was incredibly interesting. For the what else have I done? The previous company, I helped create a model, create slash improve, mostly improve a neural network type model. So basically, I worked at Loblaw. Loblaw is the company that owns almost most of the grocery stores in all of Canada, and so they sell a lot of food and other different items, and they make a lot of money. So basically, I worked as a deep learning intern there, and the other people, very, very smart people, were involved in creating, they had basically already created an LSTM, long short-term memory. It's for time series forecasting, which is what we were just discussing previously, a model that's trying to predict the demand. So demand from an economics standpoint, meaning like how much are people going to buy, how much do people want, as well as supply. So if you know the basic economic demand curves with supply and demand, if you don't know what I'm talking about, don't worry. But I'm guessing I got some reminders there from some people. Basically, you want to accurately forecast demand, and the simplest way to model that in economics is to draw a line. So they assume that really both demand and supply are differently, one's increasing, one's decreasing, linear curves, or linear curves, linear lines basically. I said linear line. I always really hated in high school when people said linear line because it's the dumbest thing ever. Lines are linear. Uh, um, Basically, the simplest way to model demand is to draw a line, but it's not very accurate. There's so many different variables at play, and again, I don't want to go too much into the specifics because I'll get in trouble. But the idea is, to use a neural network. It's not surprising to use something like an LSTM because it's a time series forecasting idea. We're constantly, we get the next day of data. We're trying to, once we have that next day of data, we're trying to predict the next day, the next day, the next day. So it's a time series forecasting problem. You can use many different types of inputs, and I leave it up to your imagination on the types of variables that you might want to look at if you're trying to predict what people might want to buy or how much people might want to buy in a store. Obviously, something like the price is an interesting variable. I'm not going to get into it though. And as well as always, for pretty much no matter what problem you're trying to solve, if it's a time series forecasting model, you know what the best variable is to try and predict, that variable? It's the same variable. Like if you're trying to predict the demand, obviously the demand from the previous day is probably the most important variable in determining the demand the day after. Okay, so that was a really interesting problem that I I was involved with. I did a lot of trying to promote that model in our company as well. Thanks for asking. I like talking about that stuff, and I think I think it's interesting to hear about. So you've helped me out a lot. I really appreciate that. How to start learning deep learning implementation approach. I very strongly recommend the deep learning specialization by Andrew and Coursera. I have the link to that in the description if you want to directly go to that. How to not procrastinate. I want to complete my Andrew ML course, but I'm still stuck there. I don't think you're procrastinating because you're like if it is laziness. I mean, everyone gets into slumps and that's totally fine. But it's okay that you're stuck there. And if you're really confused on particular concepts there, then you need to take a step back and make sure that you understand everything that requires that. So if you don't fully understand the linear algebra stuff you covered early, you got to cover that. If you don't understand the gradient descent calculus optimization, you really got to understand that. Just take things piece by piece. Don't feel like because you saw some don't feel like because there's week 1, week 2, week 3, and you already covered week 1 that you can't go back to week 1. I love sitting on the bare basics, and I just read, I loved reading a new book on the basics of, statistical learning theory. Yesterday, just read for like 3 hours straight. But even though I know all of this stuff, like the bias variance trade-off, underfitting, overfitting, linear regression versus nonlinear techniques, spend as much time as you want just really, really learning the basics and understanding those ideas. And then I think you'll stop procrastinating because you kind of just get it. Like it flows. And don't worry if that takes a while. Also, I'm talking, I learned this stuff mostly after a university math background. That's a very rigorous university. And so it was even a little bit tricky for me. So be steady with this stuff. Learn what you have to learn so that you can progress, and just don't worry too much. Seriously. Okay, how was your time at Deep Breathe? Really wonderful. Learning, yeah. So sorry, I can't really talk too much about Deep Breathe at this moment, but it was very, very exciting. Could you please explain what a data architect does? Not really, to be honest. A data architect, that can mean so many different things. And I am curious what the Google definition for data architect is. Um, what it is more so. So what generally these architect type words mean is it's usually not going to be a coding role, like actually like physically coding something. What it more so is one of these in between roles between like the business and the coding people, where they more so guide the direction and they say the organization of this structure. And so if you're someone like a data architect, sure, it says a data architect is a practitioner. I'll just move this on the screen. It says a data architect is a practitioner of data architecture, a data management discipline concerned with designing, creating, deploying, and managing an organization's data architecture. So yeah, you're going to be someone that kind of it's in between understanding what the business wants versus what what the people really want, as well as the developers, so you can organize how this stuff is stored and tell people kind of what the right idea is, draw diagrams on what the right idea is, not actually coding it yourself. Okay, but I'm also not the right person to ask exactly for that role because, I have never been a data architect. At least I don't know about working closely with specifically a data architect. Um, can you suggest some beginner data science projects? I have a video that is the top 5 data science projects. Just go to that video, search that out with Greg Hogg in the title, or just go to my videos list and it should be, maybe around like the 20th last video, the 10th last video, something like that. That will help. But basically the idea is MNIST handwritten digits, California housing, Titanic dataset. Although I don't usually use it, the Iris dataset is pretty popular as a beginner project. All of those are great. Hi, Argentina, very nice. And I've discovered your channel yesterday and it amazed you. Well, that's great to hear. I'm really happy to hear that. You're very welcome for sharing the knowledge. Can I suggest some basic machine learning and data science projects for beginners to upload in GitHub or Kaggle and improve profiles? So first of all, I don't want to give a false advertising for Kaggle where most people don't actually care about what your Kaggle profile looks like for the most part. Some people do if it's very impressive, but you can't really improve your Kaggle profile by, getting a couple competitions done unless they're really good results. Like you can for sure if you are getting great results that are solving important problems. But doing 5 beginner projects on Kaggle is probably not going to impress employers, but it is incredibly useful for building up your own sort of self-esteem and that's important, your own confidence in this stuff, making it feel like you're just getting better and better at the stuff, and you are, which is really, really good. I just don't want to say that it's going to impress employers to make an amazing Kaggle profile. But again, I think I just said about 2 minutes ago the projects that I'd really recommend learning a lot. Most of those don't really require using GitHub. GitHub is normally used for bigger projects, especially if you plan on deploying these projects. Many of them kind of recommend that you, or even require that you push certain files to GitHub. You have your project there, like a Flask tutorial, like a Fast API tutorial, and I have those if you want to watch those. That's probably when you'd start using Git or GitHub or both. You have any ETL and machine learning developing in your well, I have a lot of machine learning material. Please take a look if you want to learn machine learning. I have a ton of that. He works as a data engineer. Awesome. Trying to get more involved in ML and would love to see some content like that. Explore the channel. I have a lot of machine learning content. How would you do image colorization? Colorizing, like, does that mean actually coloring images or recognizing the color in videos? I don't think I've seen this word before. Image colorization API is a deep learning model that has been trained on pairs of color images with their grayscale counterpart. Well, thank you for opening my eyes to this. Oh, it's that. Oh, that's the word for that. So basically, just to show the idea here, um, and I don't really know. I haven't done this in particular. It's a very modern technique. The idea here, I assume this is Martin Luther King Jr. Someone can smack me if that was wrong. But older stuff, so like grayscale, and then they are trying to use deep learning to actually color the images and make them look more modern. And what's really fascinating, I don't know if any of you have seen this, but you know, an image or a video is just a series of images, and so if you do that with every image, then you end up with basically just a revived video of something in the past. And it's really fantastic because what I like about this a lot is that, you know, if you've ever seen older reruns of TV shows, um, you know, it actually makes it look like with the camera quality, and especially if it's black and white, but even just worse camera quality, and you can upscale this stuff with deep learning too. It makes it feel like, I don't know if I'm the only one that feels this, but like older videos, it really seems like life was just different. Like it was just not as obviously life was different and it was not as modern as it is now, but at the same time it's not like people actually were like blurry and people actually wore like gray clothes and stuff like that. I can't help but think that it's back then watching those videos, it makes life look so much different than it was, and it's not really that much different. Like we're still wearing clothes, even like stuff like tuxedos and suits are relatively common today. Although I'm not dressed super fancy today, but I really like this idea, and that's actually something that I've wanted to read the papers on how to do that. I cannot advise how I would do that right now, but you know, deep AI, obviously, it'll probably be a clever way of using convolutional neural networks, I'm guessing. Thanks for bringing that up. I really appreciate that. So, can I do an intro to GitHub? Not right now. I mean, so GitHub is, I can tell you what GitHub is and why you might want to use it. And to actually use it is very, very easy. I recommend starting with the GitHub desktop app, and I still use it out of simplicity. I somewhat know the Git commands just because it comes up every now and then. But even just using the GitHub desktop API or application, you can just, you know, make a repository, which is just, you know, on your computer, it's a folder, and they have this git.git file, which basically tracks changes in the folder. And so at first it's going to be blank, but when you add a file there, it's going to say, oh, okay, you added a file there, and it has this contents. And then you can commit that to GitHub, and if you actually do it to GitHub, that means pushing that off to the cloud. GitHub is just, you know, a cloud way of storing the changes to your files, basically, or the most current state, and as well as you can kind of go backwards in time to go back to previous states to save your work. So the main point of it is to save your work and share it with other people. So after you've kind of finished with a project, so you kind of just leave it in a state on GitHub where other people would be happy with it, but it also tracks all of your changes. And so even if you don't want to show all of this work to people, you still might want to use Git to just commit any changes that you have, especially if you do something like make a bigger project where one really good example that I have is the requirements file for making Python virtual environments, where this is something that you kind of build up over time normally. When you keep adding libraries to your project, you keep pip installing, so you pip install this and that, TensorFlow, blah, blah, blah. And it is good to keep kind of track of these different changes to understand how your library is how your folders are evolving, and in general, it just saves your work. So that's the idea. Which book would you recommend for machine learning / deep learning for beginner to intermediate people. Um, Probably the classic, what's it called? I always forget the name of this book. It's the hands-on one with the scorpion or whatever. Not scorpion now. It's the reptile thing. I would recommend this book right here. Hands-on machine learning with scikit-learn, Keras, and TensorFlow. Second edition is important. I have the first. For some reason, I bought the first edition like right before the second one came out. I would, if you're going for a book for beginner to intermediate, this is probably the way to go. My recommendation. They asked me not to leave empty-handed there. I'm definitely leaving empty-handed because I already own that book. Okay, one childish thing though, I doubt it. In one video, I had some giveaway in November, December. I did write the right answer and sent you the LinkedIn request, but I didn't respond. I I say yes to all LinkedIn connections, so something must have happened. It is extremely, extremely rare that I decline a LinkedIn connection from you guys. So I don't know what happened there. Did you send me the message? So what happened there? At the giveaway, yeah. So if you're talking about the code thing for when I said I would show people's resumes, I sent that out to a bunch of different people. And for the people that responded to me, and almost everybody declined. They just didn't answer me, and so I didn't really end up doing it. There was only like one person that did it, and I'm still planning on doing that at some point. But try again. Sorry, I don't know what to do about that. Canadian startups that freshmen can target for internship. You're in third year undergraduate from India, working on NLP projects, open to learn anything. Great. NLP is something that we use a lot over here in Canada. There's a lot of companies that are trying to do it. I'm not going to say, so I don't even really know off the top of my head specific startup companies that are using this, but there's a lot of companies. Check on the LinkedIn job boards. Go ahead and apply at any time. If you're looking for internships, then yeah, you said internships, so that should be in the title. You can search for that in LinkedIn as well. Which industry do I work in, if I don't mind sharing? Right now, I do not work in any industry. Last co-op or last internship, I worked at in the medical industry. The one before that, I worked in the retail industry. The one before that, I worked in the insurance industry, and then government stuff. So a lot of different ones. In data science, you can really do whatever you want. So you can, if you learn the basic skills, you kind of just go ahead and apply to whatever suits your fancy at the time. Maybe I didn't ask in the correct way. I'm wondering if you have it develop where both ETL and machine learning are present. Oh, I'm going 100% going to look at all the channel content though. Okay, so ETL and machine learning are present in the same kind of video. Well, ETL is more of a company term, to be honest. Extract, transform, or transport load. I always forget what the T is. But the main idea is just kind of getting data in some format, maybe JSON, maybe CSV, maybe streamed very like live. But no matter what, you get data somehow, you do some sort of transformation, which very often implies, especially in companies like using PySpark or Spark to do some sort of transformation on a data frame. And then you send it off or whatever. It really just means getting data, you doing something with it, and moving it around. And so, do I in particular have a video where I use the term ETL and do machine learning with it? I don't think so. And maybe I do. It's really up to whatever you define ETL as. But no matter what, I have a lot of projects that take in data, do something useful with it, do machine learning with it. Okay, so can I make videos on MLOps? So again, MLOps is basically just, it's a fancy word that we've been using that encompasses all of the stuff around deploying models, training models, and not training models in the sense of not just the code that actually like writing the code to train the model. It's more about the businessy style of how often do we train this model? What data should we use? Where do we deploy it? How do we stream data? Should we immediately take the data that we're getting and make that help train the model? Should we immediately take that data and use the model? Whatever. So MLOps is a huge. It's just a term that means all of that stuff. And the best way that I'm trying to show, and maybe I should start using the term, because I guess it's confusing some people. But the Flask tutorial, the Fast API tutorial, deploying those models using TensorFlow Lite or just TensorFlow itself, or maybe scikit-learn, is this my way of showing the ML ops portion, and it's kind of difficult to, or sorry, as well as Git and GitHub, using all of that stuff and deploying it on the cloud, is the best way that you can show to employers right now that you know ML ops. And I appreciate that this term has been come up so many times, because I will make a greater emphasis on doing that, on using that term in particular. But the best way that you can show that you know that stuff is just to make deployable web apps, or maybe an Android app or something like that, where you deploy a model, and then you'll get really into the ML ops kind of businessy portion when you actually go into the job and start doing that kind of stuff. Thank you for asking that. I appreciate it. Hello, I've been following you for the past 5 to 6 months. I really appreciate that, and improved a lot of your skills. I'm really happy to hear that. You are very welcome. Do you have Insta? Facebook page? No. So actually, let me talk about that. I do decline Facebook requests, and that's because I want my Facebook to be kind of a personal thing, and so I leave LinkedIn. LinkedIn is the way to follow me, YouTube or Twitter, or even GitHub if you want, as the way to follow me, but I do decline Facebook requests, even though I do a lot of sharing my content on Facebook. And to be honest, probably 75 to 80% of you probably came from Facebook at some point, at least early on. So I hope that explains that. Do I have Instagram? I think, yeah, I do technically keep my Instagram running, but I just couldn't find, and maybe if you guys have ideas, then make sure to let me know, or maybe I just need to be more creative with it. But Instagram is obviously for pictures, and I never found it super exciting to, I make a video and then I post some interesting picture about it, or maybe me doing a vlog like thing where I'm going out and doing data science. I just never found it super interesting, and so I didn't really keep it. Course for machine learning and deep learning, Coursera, check the description down below. That should answer your questions. That's my recommendation. Can I collaborate with you in any project? I get this asked a lot. I followed your work, inspired a lot. I have a couple of internship experience in computer vision, so not a novice. I don't know what that means. So I get this request rather often. Also, the sun's getting in my eyes. That's getting a little annoying. A lot of people say, can I collaborate on a project with you? I have no idea what that means. If you have some sort of business idea where you know how to make money and you want me to be involved in that, then possibly. If you just want my help where we're together coding stuff, that would have to be a paid thing. I can't just spend my time going one-on-one making projects with people. It's not a way I can afford to spend my time, unfortunately. I wish I could, but I can't. And if you want to kind of follow what I do more closely, then message me and we can figure something out. But in terms of, I'm trying to answer this for everybody, collaborating on projects together, I can't really do that, unfortunately. I'm a regular viewer in your videos. That is awesome. Great to hear. Could you please let me know how effective Coursera courses are to be a data scientist? I'm glad you asked. I freaking love Coursera. And the reason is because they teach the stuff in what you actually have to learn. And so there's many courses out there. Some I like as well. There's some Udemy courses that I do like. Their deep learning course and machine learning courses and their Python courses are great. They're very hands-on. But the Coursera stuff to learn something like machine learning and deep learning to the degree of passing the interview is kind of tricky. And you don't necessarily need to know all of the math. You don't necessarily need to have taken 2 university level linear algebra courses or 3 or 4 calculus courses at the university level, or all of that stuff. It doesn't hurt, and to be honest, to actually get a data scientist job, a good undergraduate degree at least is extremely beneficial, very beneficial. But to really fully understand all of the stuff that's important for machine learning and deep learning, you probably don't have to learn all of that theory. And so Coursera, their machine learning course, they assume that you know very, very little. And so they say, okay, if you don't know what a matrix and a vector is, we're going to teach you what those are and why they're important. We don't throw, years of theory at you. We say why they're important, and this is how to use them, and this is how very, very soon afterwards how to implement that in something like they actually use Octave. It doesn't matter what programming language you use to learn this stuff. Of course, you'll use Python very soon after in the deep learning specialization, which I highly, highly, highly recommend doing that as well, probably after the machine learning course. Then that's the way to go, in my opinion. Again, for the deep learning specialization, I feel like I should say every 10 seconds how important deep learning is because I get so many questions and I can tell just from the general consensus that people are avoiding learning deep learning probably because of the freaking daunting term that is deep learning, and it sounds extremely complicated. Really, it's just a nonlinear statistics model, so it's like linear regression, but slightly more complicated because there's more parameters, there's more coefficients in the model. There's non-linearities like a ReLU activation or some activation functions, but that doesn't matter. It's just a complicated statistics function. And once you get past that kind of stumbling block of what this huge daunting thing is, somehow it kind of all fits together, and that might take a little bit of time, but the engineering machine learning course and the deep learning specialization will greatly, greatly push you towards that, and hopefully give a lot of motivation as well. Okay, how much how much time how much time would it take to be a data analyst learning phase? Okay, while I answer this question, a lot of people watching, I want to make sure I have some questions to answer after I answer this question. So please, if you're watching right now, just throw a question out there that you think you want to get answered or you just find interesting, and then I will carry on. Okay, so also, by the way, if you wouldn't again mind dropping a like on the live stream, it really, really helps me out and helps promote this and get people to join. So I'd appreciate that a lot. Thank you so much. How much time would it take to be a data analyst in the learning phase? So data analyst versus data scientist. Data analyst is a fair amount easier. Basically, data analyst is a stepping stone towards data science. So forgetting that data science is a thing right now, analytics is not that bad. What skills do you definitely have to learn? SQL is probably the biggest tool that you can learn as an analyst and probably as a data scientist as well, to be honest. And you probably should also learn something like PySpark, which SQL will be incredibly helpful towards that. Yeah, basically handling big data. How do you do that? Well, you use PySpark is the most modern way to do that. But before you learn that stuff, definitely SQL, basic statistics stuff. So you should understand what histograms are, the different graphs basically. So histograms, scatter plots, box plots, all of that stuff is really important. Stuff like averages and standard deviations are your best friend. So like variability, really, really important stuff. Do you need to understand all of the probability, nitty-gritty statistics stuff to be a data analyst? Probably not. Probably not. But all of that stuff doesn't hurt. And for an analyst role, the requirements, by the way, you should learn Python or R. Sadly, for those that know me, you know I don't like R in the slightest, really, even though I've used it over and over and over again, been forced to use it. I much prefer Python, but for strictly sticking as a data analyst, R is probably not necessarily the way to go because I still think PySpark is the most modern way to do analytics and what's going to be most required. But R can do actually a lot of work for you. Hurts me to say it. Okay, could I recommend some Udemy courses? I can absolutely do that. There's a few Udemy courses that I really, really like. The Python A to Z course, the machine learning A to Z course, I believe it's called A to Z, machine learning and deep learning courses. I like all those three, and so in most of my videos, if you go to this live stream, the description of this is a little bit out of date from my normal videos. If you go to any of my videos, probably in the last like 10, 20 or whatever, you will see the few that I recommend in the description. So those are the ones that I like. The reason I don't really talk about Udemy quite as much as I do for Coursera is because I feel like Coursera does a better job at getting you to that interview level of understanding all of this stuff. But Udemy can be very, very good, especially if you do know some of the math already and you've done some reading on all of these topics before. Or if you're a brand new a beginner and you just want to kind of see about what the code is doing to understand data science and machine learning, or if you're just trying to learn programming, if you are trying to learn programming, their Python course is actually very, very good, and probably better actually than the Coursera Python for Everybody course, but they're arguable. Of course, the downside to Udemy that probably everybody knows is that it is not free. I don't believe, correct me if I'm wrong, I don't believe there's any way to get Udemy courses for free, at least legally. And so that's why I often recommend Coursera, is because I like recommending free content for you, because learning should be free. And if you want to pay for the certificate, I think the certificates down below are incredibly valuable. But I also don't, I like recommending the material because it is free, it is excellent material, and if you think that paying for a relatively cheap certificate, I mean, it's not super expensive, it's also not super cheap either, to get a certificate, then that's something that you can choose to do, which I think would be a great payoff. But I always recommend that material if I can. Yes. Okay. Yes. Wait, I'm confused where I'm at. A regular viewer, can I, like, how effective? Yeah, I answered that. How much time would it be to do a data analyst? Or answered that. Could you recommend some Udemy course? I just did that. Having a completely different degree, architecture. That is a pretty different degree. Is it possible to find a job in this field with the Coursera certifications that you suggested? So the answer is yes, for sure. Man, the sun is really getting in my eyes, so I'm gonna take a step back here and move the mic like that. That is getting really annoying. So basically, yes, you definitely can. You can become a data scientist, and your degree is still helpful because it shows that you've done an academic background. But I will say that it is kind of difficult. To get a data science degree, they do generally want that you have some sort of undergraduate degree in math or computer science or engineering or something like that. And it is difficult. What I would recommend for you is probably to step into an analyst role at first, because analyst roles are even maybe a little bit more common and definitely easier to get into. And so learn SQL, get the certificates like the IBM Data Science or Analyst certificate, and try to learn machine learning, try to learn deep learning, get a data analyst role, and then that'll kind of show employers that that you're more serious about this stuff. It will be pretty tough. I don't want to be super optimistic on saying get a couple of Coursera certificates and try to become a deep learning engineer. It's not impossible, but it is relatively difficult, I would say. And of course, maybe in your situation where your degree is very different than than like a STEM field, basically. Or I mean, it's yeah. I think it's okay to say that. Then maybe you could consider doing a master's in something like analytics or artificial intelligence if you are that passionate about it. That would again kind of show employers that you are serious about this, that you are pivoting, and that you have the skills to do so. It is difficult to have a degree in something completely different and just get a couple of Coursera certificates and claim your worth. It may or may not work. That's my recommendation. I hope that helped. Make sure to ask any extra questions if you have those. Statistics topics are hard for me to understand. Yeah, they're hard for me to understand too, and I'm a statistics major. So stats is just hard. Like all the random variable stuff, especially when it gets more and more advanced, it is very difficult. So that's okay. Statistics topics are hard for me to understand and apply, even being from an engineering background. Yeah, how should I go with the stats topics? Well, so firstly, you need to be careful, not careful, but be mindful about what it is that you're learning and how helpful will it be. There is a lot of stats concepts like Markov chains, and you can go down a huge kind of rabbit hole of all the statistics stuff that may not be super important for becoming a data analyst versus a data scientist. This is when I think the Coursera and Udemy courses can really shine. Is they guide you in the direction that employers actually care about. And if you do have some sort of a degree, you're welcome, by the way. Um, if you do have some sort of a degree in the field, or yeah, undergraduate or master's degree in the field, and sorry, I kind of lost my train of thought when I read the thank you. Yeah, so Coursera and Udemy courses guide you in the right direction. And if you do have some sort of academic background proving that you're trying to learn this stuff and that you're relatively good at it, then it doesn't really matter about becoming a complete master in the statistics or in all of the math stuff. It can be helpful for sure, but that's when I think something like the engineering machine learning course or deep learning specialization can really push you and tell you what employers actually care about. And that's why I love them so much. Is yes, the material is great, the material is free, but it really pushes you. Hey, Bennett. Hey, how's it going? I'm so happy. I'm so happy to see you. We should play Smash. Yeah, let me know if you want to do that. Yeah, so basically, if you now I lost my train of thought again. Thanks, Bennett. um, Stuff like these courses really push you in the right direction because there is so much stuff that they teach you in a math undergraduate degree, like these linear algebra and calculus courses and statistics courses that are beneficial and help you in interviews and help you learn stuff a lot faster, but they're not necessarily better than it's not necessarily necessary. That's an interesting way to say it. Necessarily necessary. I'm being silly. Hi, Greg. I'm working as a big data engineer and want to switch to data scientist role. Can certification? Awesome. Yeah, we should actually do that. Hi, Greg. I'm working as a big data engineer and want to switch to data scientist role. Can certification courses help me gain the knowledge? Yes, so the knowledge for sure is what they're really good at. Can you please recommend a good course? If you're trying to switch to machine learning, I really, 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 really recommend the engineering machine learning course and the deep learning specialization. There's also Udemy courses. I don't like them quite as much. They're also paid. They give you the basics, and yes, they can be a little bit confusing, and you have to take your time with it and make sure that this stuff is really resonating with you and not keep pushing yourself. Since you did week one, and you moved on to week two, you can always go back to week one, and you probably should go back to week one and take your time with this stuff. But they push you no matter what. They give you the background that is necessary. So stuff like linear algebra, they teach by giving you, this is what a matrix is, this is what a vector is, this is matrix vector multiplication, why do we want to do this, and that's it. They don't go into the crazy, field of linear algebra that I'm scared of. I've been there before and don't really want to go back. A lot of it's not necessary, to be honest. Some of it is. Stuff like principal component analysis goes heavy into the linear algebra for like eigenvalues and what's the other one? Singular value decomposition. All that stuff that I hope that you never really learn about, to be honest. So yeah, that's how I'd recommend moving into machine learning. If you are already a big data engineer, that is great. That means a lot of employers are going to respect that for any sort of analytics job. That's awesome, and you are in a great position to just get some Coursera certifications. This is where I'd recommend the Coursera certifications, by the way, because it does show employers that you're a big data engineer, you understand the stuff in the company, but you get a couple certificates to show that you've learned machine learning and deep learning, make some projects, and show that you're passionate about this stuff as well, and you're in great shape. Which sector is the best for working as a data analyst to work in like? Which sector is the best for working as a data analyst to work in like? What is like? Is it healthcare? Oh, like is it? Okay, now I understand how to read that sentence. Which sector is the best for working as data analyst to work in? Is it healthcare or finance or any other sector? Beats me. I don't know. Whatever you're passionate about. I really liked the data analyst, or not data analyst. I really liked the healthcare stuff. Bennett would know that if Ben is still there. but, there's lots of good opportunities, and you learn really about whatever domain that you want to. If it's something super fancy and awesome like self-driving cars, then that's great if it's that niche. If it's just learning how to recommend products, or learning how to sell products, or make whatever domain it is better in any capacity, then you can do that if you learn the generic skills like SQL, and PySpark, and hopefully machine learning as well. You can do all of that stuff, whatever you want to. Okay. Dumb question. Good, good. I love when things start with dumb question. In architecture, to find a job and to shine, we use portfolios, and they have a yes. I've heard that. I would think it does. Is it the same in this field? Yeah. So basically, it's the same as it is for architecture. Like you show your portfolio, but your portfolio is online. I'm sure architecture has slightly moved in that direction as well. But it's about showing that you know software, Git and GitHub, Linux and Unix commands, Python, SQL, PySpark, Python libraries, fancy projects like Flask and Fast API tutorials. All of that stuff is your portfolio, and your LinkedIn is incredibly valuable to make that as best as you possibly can. Since I don't have a degree in the field, but I can prove ability with some personal projects. Yeah, that's the other way to do it. Or in combination, personal projects, portfolio projects are very useful. It's a good question. It is a good question. Do you see opportunities of using data science in finance? Of course, it is incredibly common to be used in finance type fields, as well as just finance being incredibly common as well, because unsurprisingly, yeah, every company is trying to deal with finance in some capacity, and it's a very analytical thing. Nonetheless, it's not something I'm incredibly passionate about, and so I don't really love to, you kind of have to take some accounting like courses, businessy courses, to understand that a little bit better. It's not really something that I am incredibly passionate about, hence I don't really, I mean, the closest to that was insurance. Insurance is actually pretty close to finance. But even then, for me, it's not really where my huge passion lies. I care about solving interesting problems, and so that's what deep learning can do. It's why it's so closely associated with artificial intelligence, making interesting, intelligent machines. That's where my passion lies, for the most part. Okay, it seems like we've hit the bottom of the questions. How long am I going to keep going for? It's 11:30. I guess I've been going for an hour and a half now. I mean, I guess I'm in no real rush to go, to be honest. I don't think I have anything planned. So, keep asking questions, keep going, keep going. Or if you want to see a tutorial on something, then that would be okay as well. I could do some live coding if the hard majority wanted to do that. Because I don't see a lot of questions flying in. That's okay. Actually, no, it's not okay. Keep asking. Did you try 100 days of code? Actually, let me just let me put a poll out to see if someone wants to switch it up at all. So coding tutorial. Do you want to? Let me just write the whole thing. Do you want to see a coding tutorial right now? Ask my community. Hello, community. Did I try 100 days of code? No, I did not. I don't plan on doing that. Man, it shows my face is super bright, which that sun is so annoying. Basically, I really need to get around to fixing my blinds, and the sun just kind of flies in here. Okay, answer the poll, please, if you see that in the chat. 2 for yes so far. I'm gonna have a quick drink break over here. 4 for yes. Okay. If your answer is no, please actually write no in the poll, because it would help me understand that a lot better. 7 out of 7 for yes. Really? Okay. You want to see some coding? I like coding. A few more people, could you please answer the poll in the chat? All right, getting some no's. Okay. All right. Again, please keep answering that poll, and we'll decide that in a minute or two. Can we use C++ for TensorFlow? And if yes, can you please make videos on that? um, I do sort of kind of know C++. It's definitely not where my passion lies. A lot of people's passion does not lie in C++ because it's a difficult language. It's hard to be productive and move quickly in C++, and so it's not something that I love. Is it useful? 100%. It's incredibly fast. It's still one of the top programming languages as well. Definitely in something like TensorFlow. TensorFlow is all that stuff is written in C. So yeah, you can. But to actually do the stuff in TensorFlow in C++, there's not a huge point of that. And the reason is because it's not that much faster to actually have written it in C++ versus in Python, and most machines are okay with the majority of them are okay with having Python as well. Like most of the Arduino kind of robots where you might think about normally doing C++, a lot of that stuff is moving to Python because it's just converts to C code anyway, and so it's very, very fast. I have probably little plans for the near future anyway for C++ like content. To be honest, I would probably find that from a different person. I'm not really down for that. Okay, I am seeing a pretty overwhelming, very overwhelming tutorial right now, so I guess I'll have to ask what that is. If that'll be great. I might change the title of this from Ask Anything to Live whatever tutorial. Okay, so I'm going to answer the questions that are there first, and then I will talk about the tutorial right after. You're a data science student from Israel. Hello, working as an intern as a data engineer and can't decide what is the best fit for you, data science or engineering? I don't know. I'm really passionate about data science, but I can't really tell you what your passion is. Sup, Greg? Sup, David? I got a math and statistics undergraduate degree, and I'm starting my master's in stats. Great. Sounds like you're off to yeah, you're doing great. I got a job at a small company as a data scientist, but the only thing I've done last month are dashboards. Welcome to reality. Yeah, that's life. That's pretty common for companies to advertise something like a data science role, and they'll be throwing you in like a dashboards like position. That's why generally what I apply to, and it's obviously everyone likes something different. I'm just not a dashboard type of person. I like solving like artificial intelligence like problems, and so I generally apply to companies that say they're doing deep learning or machine learning or something like that, and they actually describe the problem to you that they're trying to solve in the interview. To actually push for that in your current situation where you are, just to recap for everybody, you got hired as a data scientist, but you're really not doing what you want to be doing. You have to take the initiative and not tell them that you want to be working on machine learning or deep learning. That would work as well, possibly, but what you really should do is just find an opportunity to apply it, and if you have permission to just start working on it in your meantime and kind of transition that into your full-time job, because it'll start providing a ton of value for them. They'll be happy with it. So really that's my recommendation, is to try and find areas to try and apply this. And I don't think it's super difficult to find generally. I don't know your situation, but generally it's not super difficult in a company to try and figure out what machine learning model might provide them some value, or what more interesting, maybe clustering type analysis might be useful. So there you go. I hope that helped, or am I? Yes. Do you think you should change your work? No, I think you should try and tweak it in the direction that you want to. I mean, get another job. I'm not very interested in making dashboards. Neither am I. Should I answer this question before thinking whether I should have a master's degree? Yeah, I don't know really what to say. Sorry, I don't have much advice on that. What's wrong with dashboards? I don't like them either. It's a little bit boring in my opinion, but everyone likes what they like. Can you please suggest some good projects to do in data science? Check out my Python projects playlist. That will help you out. Can I make a poll on the tutorial topic, please? Very shortly. Kaggle profile only on notebooks. Actually, I will make that tutorial. So it looks like, a lot of people are just kind of waiting for the tutorial because I have 19 votes here, 95% yes. So again, one thing, actually, let me just really quickly answer these questions. Kaggle profile only on notebooks help me to attract recruiters. No, not too much. Kaggle, most employers don't care too much about your Kaggle. I mean, they're okay, but I'd like to do more interesting stuff. I agree. Please, I'm an engineer in energy and I want to learn data science and machine learning. Any services, please, and how much time I need if my frequency is 2 hours a day. Thanks in advance. Just start grinding away on Coursera courses. That would be the way to go. Okay, perfect. Glad I can help you out there, David. Is there a difference between working/doing an internship in a startup or a medium or large company in terms of value and experience? It's a very different experience. Sorry for talking quickly. I hope you can still understand me. I'm just trying to get through this quickly. So basically, in a big company, things are going to start to move slower. Depending on where you are, you may solve more interesting problems or more boring problems. But things you feel more governmenty, like very, very slow, and the term is bureaucratic. Bureaucratic basically just means slow and big. In a startup, you can really just start like doing stuff right away. They want you to do stuff. They don't. It's not going to be a bunch of meetings about a stand-up meeting every morning or something like that. Whereas in a bigger company, it probably would be. Okay. Is there different? Yes. Okay. Gotcha. Okay. So do you want to see a coding tutorial right now? It has 90% on 20 votes. So that means 18 people, very, very close to everybody. So very clearly, you guys are waiting for me to do a coding tutorial. What do you want to learn? So let me make a poll on that for sure. It is difficult, and I wouldn't blame. Why can I not do? There we go. Create a poll. Yes. Come on. Create a poll. Okay. So I wouldn't blame some of you for leaving after we figure out what the tutorial topic is, because it's hard to treat everybody in this right now. But I will try and please. I will please the majority as much as I possibly can. So I will ask. I'm not going to do Python. So just it will be in Python. That's all I really want to do. But it's not going to. I'm not going to be doing just a Python tutorial. Stock prediction using artificial neural network. That's a kind of a tricky one, and it's not. I'm not sure if I could super easily just do that without any sort of practice. I might. I will make that a future video though. I like the idea. Let's ask. So I assume that the majority of people aren't incredibly advanced in machine learning and deep learning. So let me just ask if basic machine learning tutorial. I'm just going to put that as a yes or no. And hopefully this is a majority yes. Any end-to-end projects on NLP or computer vision? I can't do that for you. Like it would be really awesome if I could just, without any sort of practice, go and make like an NLP. Well, I can't make an NLP project. I probably could do a computer vision project because I've done it so many times. But this is more so going to be basics. I'm seeing. Okay, please answer the poll in the chat. By the way, that's what we're waiting for to decide. Okay, good. It looks like most people are down for that. I do apologize for this. It may be not being an incredibly advanced tutorial. I'm probably not going to do something like figure out how to deploy a new project on Heroku or Flask Fast API, that kind of thing. We could still do computer vision because image classifiers are, well, I don't know if it's easy, but it's something that I've done a million times before, so I'm sure we could figure that one out. Okay, so 9 out of 10 so far said basic machine learning tutorial is going to be a yes, so that makes me very happy. And I'm sorry that I can't please everybody. I really wish I could, but it looked like pretty much everyone wanted a tutorial. I will actually change the title of this to live machine Learning coding tutorial. And the thumbnail shows Ask Me Anything, which is not amazing, but I guess that's probably fine. Okay, so 92% on that. I guess we'll be doing that. So for those of you that I know that are going to leave because we're going to be doing a basic machine learning tutorial and you already know all that stuff and you don't want to see it, then thank you so much for stopping by. Next time I look forward to seeing you. But that's what we're going to be doing right now. So for the at least over 10 of you that I know are going to be here, let's enjoy this. Okay, I'm gonna leave that poll there just for now, and let's make a tutorial. I think that a deep random forest coding would be great. People tend to forget the old and strong classics. A deep random forest. I mean, yes, deep does kind of mean something in random forest, but that sounded a little bit confusing because I was thinking of neural networks. I'm gonna save that. Yeah, so for some reason my background on this computer, it just kind of died. And yeah, it's just this black screen, which is kind of weird. Okay, hopefully when I move towards the computer, it's the sun's not glaring in my eyes again. And do let me know if I mess up the sound quality at all while this is going, because I'm moving it around a bit. Okay. So let's get going, and I use what I always use, which is Google Colab. I'm going to set up a little bit just off the screen for now, so I don't show something I don't want to. Not that I really think there is anything, but here we go. Okay, we got Colab going. So a basic machine learning tutorial. We'll also make a random forest as well. I don't know if I want to bother making another poll because it kind of takes a little bit of time to get the answers back. By deep, I mean a profound study of random forest. Oh, I won't be doing a profound study of random forest. I'll probably import one from scikit-learn. I'm not going to be showing all of that stuff. So we can do California housing or MNIST, or I guess we could get something from Kaggle as well, but I'm gonna stick right now with okay, so I think I can make most people happy by doing the MNIST handwritten digits one. So what we're gonna do is so we'll just look at what actually MNIST is a little bit better if you get it straight from TensorFlow, so we're gonna actually ignore the CSV there, and I'll see if I remember the syntax exactly, but this is, again, you start looking up syntax right away. From TensorFlow.Keras. I think it's datasets import. Is it MNIST? I think you can do that. And then to get the NumPy arrays, I think you can do xtrain, ytrain, and xtest, ytest. If we let that equal MNIST.load data, I think I have that memorized right. And then I can ask for the shapes of these objects with dot shape and dot shape and dot shape and dot shape. Okay, so there we go. Downloads the data. And so here, so we have xtrain. This is going to be our input matrix. This is going to be the variables that we use for training the model with the input part. Okay, so it's going to learn how these features start to map, learn the patterns in these, how that maps to the corresponding outputs here. Here's the input matrix, here is the output. So if we look at xtrain sub 0, so this is the first thing. This is some messy thing. Why is that? It's because it's a picture. So I love matplotlib, the basics of it, because you can do very simply import matplotlib dot pyplot as plt, and then this is an image, so we should just be able to do plt.imshow of xtrain sub 0, and that outputs this very weird looking thing. I'm going to zoom out a little bit, it's pretty zoomed in, and I think I could do full screen as well. There we go, that's a little bit better. Okay, so here's our first input, xtrain sub 0. It's the first of 60,000 images that we have. So this, you can see 0, it shows a little over 25, that's the 28. So these, in this xtrain thing, this xtrain, it is a NumPy array that has 60,000 of these things, where these things are 28 by 28 images. Okay, so it shows some color here, but actually there's really no color to this. And there's a way in Matplotlib, if someone else wants to grab me the syntax, then I would do it. Otherwise, I'm not going to bother, to really show that this is a grayscale image, meaning it's just each of these values here, each of these 28 by 28 values are just a brightness. And this, clearly there's no brightness here at all. All of this area is just blacks. And so if you again look at xtrain sub 0, you see a lot of zeros and a few brighter values. In fact, the values of this, all of these values are going to range from 0 to should be 255 or maybe slightly less. If we look at xtrain sub 0 dot flatten. Flatten means we just kind of stretch it out, and forget the fact that it's a picture. It just stretches it out into big long stack like this. And so it takes this vector, and then I'm saying vector because it's just a bunch of data, a bunch of numbers. So we take this vector, and then we get this vector, and we stack that on this one. We get this vector, we stack it on this one, and we keep stacking the image and flatten it until it's this big long stretch thing. And so xtrain 0.flatten, if we ask the shape of that, then that's just 784, where 28 times 28 is equal to 784. That's how we got that. Okay, so then that's the shape of that. And the point of this is to show, if I ask I'll just do the numpy.max of this thing to flatten, then it's not defined because we have not imported numpy itself yet. Import numpy as np. Then we get the max of that. Its max value in the picture is 255. The minimum will be 0. So all of the values in every single picture are between 0 and 255, and they are single channel, meaning we just have 28 by 28 here. In colored images, you would see RGB for red, green, and blue values. We don't have that. We simply have these grayscale images. Each of these pictures are 28 by 28. Now that we understand what the input is, let's look at the output a little bit. The output's a lot easier to understand. I'm going to just remove that. And I'll actually remove that as well. Okay, so ytrain. What is ytrain? Ytrain's a bunch of just integers. So this is a 5. This is just saying the output. So the first output here, this is a 5. Notice that we have 60,000 of these as well. These match up with the inputs. And so this first image corresponds with this first output. We're trying to map the input, which is the picture, to the output. We're trying to learn the pattern. So ytrain, the first one is a 5. We need this data to be labeled. We need it to be some way of storing, hey, this is a 5. Hey, this next one is a 0. If we show xtrain sub 1, then that's a 0. It's labeled as a 0, and you know that if we were to do 2, then it would be a 4. Okay, so we're trying to figure out, we're trying to make a function that is able to map the inputs roughly to the output of the of whatever that input is. We're not going to get 100% accuracy. We are not trying to define some sort of model that figures out exactly every single possible configuration of what a 4 can be, but we're trying to look at the general pattern of, okay, a 4 looks kind of like this, or maybe, something like this, that'll be a 4. So that's the idea. So how do we train a machine learning model that goes about doing that? Well, there's a lot of different ways. In fact, you can really choose any sort of machine learning model that you want. And probably the best option would be something called a convolutional neural network, which we'll build up to. But it turns out that since we only have, and 784 seems like still a fair amount. Where do we have it? No, I got rid of it, but 28 by 28, we have each of our images, each of our data points are 784 dimensions, which seems like a lot, and it actually is a fair amount of data. But it also turns out that even something like a random forest that really, really looks heavy into all of those different features, which is different than something like a convolutional net, which we'll look at later, it turns out a random forest will actually do pretty well in this model. How do we make one? It's incredibly easy. It's incredibly easy. From sklearn, so this is scikit-learn, you import it from sklearn. From sklearn so we'll do a random forest at first. It should be in ensemble. From sklearn.ensemble, we'll import it's all this stuff is classes, so it's going to be capital letters. Random forest, we want, okay, so what are these ones here? Embedding, we don't want embedding. But classifier versus regressor, what are we trying to do? This is a classification problem. This, we are trying to figure out if this is a 4, or it's a 5, or it's a 0. And so the possible outputs are one of many classes, we say. So it's between, in fact, we have 10 different classes. It is either a 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. And that's it. So 10 different classes, 0 digits 0 to 9. It's a classification problem. We import random forest classifier as a result. If we were instead predicting a continuous value like the height of someone, or you know, any sort of just numerical number that you're trying to predict, then you would do a regression, but we're not. So now we'll do, we'll just call this random forest. So we're making whatever variable we want, rf. I'm going to actually close the tutorial because clearly we're getting this tutorial anyway. We can do rf is equal to a random forest classifier, bracket, bracket. And then, so here is actually where you'd specify the different things that you can tune for a random forest. And there's a couple different things. You can check the scikit-learn documentation, and we'll probably look at those in a little bit. But right now, we're just going to leave it as the default. And so we do that. Dot fit, what are we fitting it with? It's always going to be xtrain, ytrain. We're going to see this pattern a lot. Because you're fitting it, you're saying, here's our inputs, and here's how they match up with the corresponding output. We're doing something called supervised learning. It's supervised because each of the inputs, they're supervised, meaning we have labeled what they are. We know what the corresponding outputs are. They're in ytrain here. We fit that model, and then, okay, so what do we want to do? Well, for a classification problem, there's a lot of different ways to evaluate the error, but a very simple one is to evaluate the accuracy. So from sklearn.metrics, import, I assume, accuracy score. There you go. I don't think I've actually ever used that before. We'll look at something better shortly. We can do accuracy score of what? Well, we want to look at the test accuracy. We care about the training accuracy as well, and in fact we'll just look at that right now. So rf.predict, we're getting predictions with the model. What do we feed that? It has to be the input data. So this, we'll look at the accuracy of the training set. So rf.predict xtrain and ytrain. Okay, so we have not touched the test stuff at all. In fact, we haven't even really talked about why you would need that. We'll see very shortly. But this is saying, okay, we fit the model on the training set, and this is the accuracy on the training set. I have not coded this exactly before, so let's see if that works. Found array with dimension 3. Estimator expected less than or equal to 2. This makes sense because we are feeding this data. We are feeding it 60,000 28 by 28 images. But we actually need to flatten this because random forests don't really understand pictures. We'll find out there's a way of making it understand pictures, where if we just do reshape, where we keep the 60,000, but then we just write 784, and what that does is it flattens the 28 by 28 into just a 784 dimensional vector. And then we'd have to do that for the same down here. So we would just copy that over there. That should work. Okay, so it's taking some time to train the model. Random forests are a little bit heavy sometimes, especially with the 784 dimensions. It takes a little bit of time to train that model, but it's not super bad. I do not believe that switching the runtime to anything else. So we do here change runtime, hardware accelerator. If you've seen this before, try and make things faster for training models. I don't think GPU or TPU would really have much of an effect at all, because I think all the scikit-learn stuff is done in the CPU. Maybe someone can correct me if I'm wrong on that, but I think that's right. Yo, what's up? Thank you for making this tutorial. You're very welcome. Okay, so we got 100% accuracy. Really? Okay, that's not what I was expecting to see, but I'm pretty sure that that's correct, that we got 100% accuracy on the training set with a random forest, which is phenomenal. No, it's not. So we'll see why this is not phenomenal. very shortly. So this was data that we used to train the model, and it got all of them right. Many of you probably think that we have an amazing machine learning model that can now figure out exactly, if you give me any new inputs, what the corresponding outputs would be. I have no proof to see otherwise, but very shortly we'll see X test. If we do this, not 60,000, we have 10,000 of these. So 10,000 and then 784 and then Y test. So what am I doing here? I'm outputting the accuracy of that trained model. So we trained a model, and now I want to see the accuracy, how well it performs on data that it hasn't seen in training before, because it trained on this one split of data, and now we're going to see how well it performs on this other set of data here. If we do that, we can see it's 97%, which is pretty good. Actually, it's a very good model, to be honest. But it's not close to the 100%, or at least it's not super close. And the reason for this is because basically we're doing something called the concept of overfitting here, where we train and we really basically memorize what the training set looks like, and that's the model that we create, and it doesn't do quite as well as it does on the test set. We will look a lot more into this soon when we look at neural networks on how to adjust that. You can also adjust this in with these parameters here. So actually we'll do that right now as well. I'm going to grab the sklearn random forest documentation because I forget what they're called. Actually, I can probably figure it out right here. So a little tip that probably a lot of people don't actually know is if you run help on, I think I could either choose a few things, but I'm just going to grab the variable I made for the random forest classifier. If you call help on that, it's going to return basically whatever doc string that they chose to do here, and it's very good. So they have a lot of different, lot of stuff here, but the important stuff is, okay, n estimators, int, default equals 100, the number of trees in the forest. We can adjust that value. So let's, for now, just adjust the, and also I'm going to, not like this, that's fine. We'll leave this as is and change n estimators equal to maybe 10. Okay, so we chopped by a factor of 10 the number of trees that we have in the forest. And if you don't understand exactly what that means, it doesn't really matter, to be honest. It can be important for interviews for understanding that stuff, but also this is pretty much fine. You can see we did a little bit worse on the training set, still 99.9 accuracy, so pretty good. And we did a fair amount worse on the test set. What does that mean? That means, well, maybe we should increase the complexity of the model, since we saw earlier that 100 did better. Let's try even less for now and see what happens there. It's probably going to do worse. It did a little bit worse, as we expected. Okay, so let's maybe try 20. And I'm just checking my phone here, sorry. Oh, GitHub is live. If you want to see GitHub live instead of me, go ahead. No, it's not super exciting. So very high accuracy, and there you go. So it's getting better. Maybe 50 is good. So we'll try n estimators is equal to 50. And of course, this is just one parameter that you can adjust. But this is something that, this is pretty much what us machine learning practitioners do. Obviously, there's a lot more going on in the job. For who you talk to, the problems that you're trying to solve, the techniques that you do to solve them. But to be honest, it can look a lot like this sometimes, where we try and just look at values and try to do better and better and better. It looks like maybe let's go over 100. So maybe 120 estimators will do even better than that first model, which I believe was 97 accuracy, something like that. Does this do better? This will take a little bit longer to train, because the more trees that are in the forest, the longer that it's going to take to train. But it doesn't look like it's going to take super long. Okay, going almost done, I hope. Yeah, I guess I'll just hang it. So yeah, when I'm making these video tutorials, I kind of always cut the stuff out where I'm just watching it train, or I go for a walk and I let it train. But this is the reality, is that sometimes the stuff can take way longer than this, and we'll probably see a model that takes a fair amount longer as well. Come on, hurry it up. Let's go. Okay, accuracy is 100. There you go, 97% accuracy on the test set. So not bad. We actually created a pretty good machine learning model. But let me tell you something, is that for specifically image data, this random forest may have done pretty good on this MNIST handwritten digits dataset, but normally we use something called convolutional neural networks, which are much more complex models. But again, to code it is not necessarily super bad. Obviously, it's a little bit easier for me because I've done it a bunch of times. But I want to show you how to make a convolutional neural network right now. So we use these things for pictures, and just to understand a little bit about what it's doing, basically this convolution operation is going to, you can imagine a square being put on this image here. So think about a square. And then we're basically just going to take the square, put it here, 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 and we're moving this square across this image. And what it can do for us is it kind of learns, and so that's what this training, this fit process is. When I call fit with the data, it's learning how to do this. And our convolutional net will do that too, where it's learning, we move this square along, it learns how to pick up these sort of edge patterns that it sees like, okay, this is kind of what makes a 4. It kind of looks like this. And so it's generally used for image data. And also when people say convolutional net, they usually mean 2D convolutional net. You may actually need, you may need other ones like a 1D CNN or even 3D CNN, but generally people mean 2D CNN. And so let's make a model to do that. It's in TensorFlow. From tensorflow.keras. Actually, let's just, I think you can do it like this. From tensorflow.keras import layers. And then we will do from tensorflow.keras.models import a sequential model. And so what we're going to do is build up this sequential model. It builds layers of, in order, what is going to happen. And I can just tell you from experience what I want to create here. Actually, before we do the convolutional net, we'll make a simpler neural net as well that's not generally used for picture data and see how that works. Just as a beginner tutorial for sure. So from tensorflow.keras import layers, we're going to make a bunch of layers and we'll add our sequential model. So add layers to our model. So we'll do model is equal to sequential of, I will just write it like this, where we pass an empty list, and so no layers quite yet. And then we'll just keep calling this model.add thing, and this is in order the layers that we want to add. And we want to get an input. So the input, we should specify the shape of what we want to see. Ignoring the number of them, we don't care about the number of them quite yet. Thinking about just one of the inputs, what does that look like? It's a 28 by 28. So we'll model.add a layers.input, and I happen just to know this most of this stuff offhand. You'd have to look it up, and it's totally fine. But .input 28 by 28 image. Okay, so it can take an image, and it doesn't really do anything with it quite yet. That's not much of a model. It's just specifying this is what it takes in. Now, what do we actually want to do? Well, before we do the convolutional neural network part, we'll just do something more simple, which is something called layers.dense. So it takes in a 28 by 28 image, and then we're going to do, and that's why if you were here before, I really recommend just the simple matrix vector multiplication, matrix multiplication, to understand a little bit more about what it's doing here. But ignoring all that stuff, basically it's converting this 28 by 28 image into, actually I think we should run a flatten here first. It probably makes a little more sense. Model.add layers.flatten, which you already saw what that one does. That simply converts this 28 by 28 into stretching it out into a 784 dimensional vector. So we kind of lost the fact that it's a picture. We just have the individual pixels in a big vector like this. But the random forest figured that out, so we can probably make a neural network that figures it out as well. We'll do model.add layers.dense, where, okay, we're going to take the 784 and then we're going to just maybe shrink it down into 32 different values. Why did I pick 32? Well, one thing, because it's a power of 2, and so we generally do that. And most importantly, it is not incredibly large of a value. And we'll see we'll make a summary of the model to show a little more of what it's doing. But it doesn't really matter. All you need to really understand right now is it's taking these 784 values, or it's taking this 28 by 28 image, converting it to 784 values, which is just stretching it out, and then it's converting it to 32 values with an activation equals ReLU. And all I'm going to explain about this right now is that this is non-linear. Okay, this is why it's more complicated than something like linear regression or a linear classifier, is because this is non-linear. The rectified, this is actually stands for rectified linear unit, which kind of makes it sound like it's linear, but it's a non-linear function, and that's the point. We almost always use, at least in the middle, we call these hidden layers of the network. This is just layers in the middle, and so we choose non-linearities in the middle. It turns out that ReLU is an extremely common one, and the one that almost everybody right now just happens to go to. We convert it to 32 nodes. I said nodes or values or whatever you want to call it. And then we'll make our output now. So what do we want our output to be? Well, for the random forest one, it kind of just knew that we wanted to output what the class actually was. And we never even saw the result of this, this predict right here. But let me show you, I think it should be this. If I grab this and I show just the values right here, and I get the shape of it. So this is a no, like unexpected. What did I get wrong? Probably just a bracket. There you go. Okay, so I'm just predicting. I can see I have 60,000 values. So this outputs this predict function here, given the input, it's going to output a NumPy array, a flattened NumPy array, meaning it's just all of the values and there's no extra dimensions here. That's what it outputs for us. We'll see that we actually have to define this for our TensorFlow model. What output do we want to see? Well, the output that we want to see, again, for only one example, so forgetting that we have multiple, we're going to be feeding in multiple of these images. It takes in one image. What do we want to output? Well, it's actually not trivial to answer this question. It turns out the answer that we have is we want to produce a bunch of probabilities for each class. And so we have again 10 classes, 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. We want to output the probability it's a 0, and the probability it's a 1, and the probability it's a 2, a 3, 4, 5, up to 9. And so if we do that, then we can just take the model, or the output that has the highest probability and get the class corresponding to that, and that would be what the model predicts. Why do we want this more complicated probability thing? It turns out for fitting the model that it makes it a lot easier to output a probability distribution. So how do we do this? It's actually something called softmax is generally used. So model.add layers. It's actually, we just write dense again. There's actually multiple ways to do this, but this is how I always do it. Layers.dense 1, and we set not one, we want 10 here. This is the number of outputs that we want. So we have 10 classes, 10 outputs there. Activation is equal to, we just write softmax. That's going to create our probability distribution. Okay, now we can do, hopefully, a model.summary, and we'll see if I messed anything up here. Looks good. Okay, so this summary function is usually very, very good. It doesn't show the first one, which is kind of weird to me, but it takes an input, 28 by 28, and then what it does is 784, it flattens it, and then it has a dense, and so it converts it to 32, and there's 25,000 parameters involved there. It's a little bit more complicated to understand why, but it's a lot of parameters. And then we convert it to 10. Here's our final output. It's going to be a softmax. Okay, so we want to train this model. We need a couple things that, it's a little bit confusing at first if you haven't seen it before, but I've just memorized the syntax, so it's not super bad. We need an optimizer. So we do from tensorflow.keras.optimizers import Atom is a really, really good go-to. If you just grab it like that, then this optimizer will solve the problem, I guarantee it, with this model, which will also turn out to probably do a pretty good job. And then what we have to do is compile the model. So we do model.compile, and then what we pass it is, you can see there, optimizer. Optimizer is equal to, you could have actually just passed the string of Atom, But what we want to do is add them with, actually I'll make it a variable over here, is probably better. We set an optimizer, we'll just call it opt equal to atom, and we pass a value here. We say learning rate is equal to some number. And a good starting point is probably 0.001 is probably a good one. And we will definitely explore what this value is doing and why we want this. So here's our optimizer. We do model.compile with optimizer is equal to that optimizer that we chose. And we need a loss function because we're trying to minimize some sort of function to get the best model. What loss function do we want to use? Well, there's really only this. There's two choices here. For categorical, so for classification, we generally call this multi-category or multi-class classification, and so the loss functions that come to mind immediately are going to be one of two different things, which is sparse categorical cross entropy or just categorical cross entropy. I actually forget off the top of my head which is the right one to use right now. One of them will work and one of them will not. I'm going to try categorical cross entropy, and if that doesn't work right, then we'll switch to the sparse one, and I'll explain why I'm doing that. Don't worry about that right now. And metrics. So what metrics do we want to see? Well, we're actually just fine with, generally you specify a list. We'll see the list of, if we pass it just the list with a string of accuracy, then it should output us the accuracy as it trains. So that's the compiled model. We run that and it says it's happy for now. We'll see if the model, generally the errors actually happen in model.fit. So this is the same thing as it is in the random forest above. We're training the model. We specify xtrain, ytrain. As I said before, it pretty much always looks like that. We fit it with xtrain and ytrain. And then there's also something really important for us to set. Well, also epochs, which I'm going to ignore for now. I'll just call it 10. We'll talk about that shortly. Something really important is the validation data. Okay, so this is, it's showing the, it's going to be training on this data, but then it's going to be evaluating on this set of data. We pass the tuple of x test and y test. And then we let that go, and we'll see if we run into an error. Shapes 32 by 1 and 32 by 10 are incompatible. Okay, so what do I got here? I think it is because I have the wrong loss function. Let me see here if I do sparse. Is it going to be happy with that? Executing. There we go. Okay, so I did have to switch the loss function to sparse categorical cross entropy. The reason why I added the word sparse is because of the format that the outputs are specified in. And the format that they're specified in, it actually just looks like this, where it's just 60,000 for the train of the number of what they are. And so I added sparse because, and it's something I always forget and I can't really memorize for some reason. But basically, if you have data that looks like this, where it's just the number that's outputting the class, then you can put sparse categorical cross entropy. Or the other way is you do this thing called one-hot encoding, which basically converts this 5 into 10 different values where they are all either 0 or 1. And so it would be basically the first value in y-hot. If we had it as a 5, we would represent a 5 as 0, 0, 0, 0. Since it starts with a 0, actually let me put a comment so you can understand this, and for me a little bit better. So basically this spot here, this is for the 0, this is for digit 1, for digit 2, for digit 3, 4, 5, 6, 7, 8, 9. Okay, so those are all the different digits that we have. If we wanted to represent a 5 in one-hot encoding, then we would do it like this. I hope that is somewhat self-explanatory. There's not really much of an explanation that I have for that. It's called one-hot because it's hot with a 1. This is the spot that it actually is. It's a 5, and so we set that to a 1, and it's not any of the other ones, so the rest of them are 0. We could convert this whole ytrain thing into one-hots by having this whole array as this as a one-hot, this as a one-hot, this as a one-hot, and then you could have done categorical cross entropy instead of sparse, but this worked as well. So with that out of the way, we see 10 different results here: epoch 1, epoch 2, epoch 3, and epoch is a run through the training set. So what it does is actually it takes multiple runs through this training set. It took 10 runs through the training set. And it did some steps along the way. It did this amount of learning, where at first the training accuracy, this value here, where it just says accuracy, is the accuracy on the training set. At first it got 52%, then it got 73%, then it got 81, 85, 87, 88, 89, 89, 73, and it starts to slow down. And those are our accuracies are getting better and better, as we would expect. Does the one that we care about the accuracy on unseen data. We mostly care about how well our classifier can, imagine we trained this model. We want it to do well. If you were to give me this new digit 5, this new digit 4, we'd want it to classify correctly that new data. And that's what it does. We evaluate that on the validation set because it's seeing this training set as it trains, and then it's evaluating on this new data. So we're really more so concerned with this value here, but it's going up as well. We go to 68, to 79, to 84, 87, 89, and it's actually following this pretty darn closely. Okay, so if we were to add maybe more epochs, so if I were to convert this to, say, 20, I'm going to stop talking for 20 seconds to soothe my throat a little bit. Okay, so you can see a couple different things. You can see it started at 90% here, whereas before it started at about 50%. This is because this model object actually kept track of where it was before, and so really this is epoch 11, and this is epoch 12, 13, and so on from remembering what was earlier. What we're seeing here is that the accuracy on the training set is pretty much stuck at 90%, 91%. It's maybe going up a little bit more now, but it seems a little bit stuck. Okay, so one thing that we could try here is maybe it's learning too slowly. So we could try here, maybe we could increase this value on the learning rate, which basically means learn faster. Why would we not want to just learn as fast as possible? Well, we're going to see that very soon. If we were to do this, we will I usually like to just rerun this part to make sure that it's actually resetting everything properly. So just define the model again, set it to blank, and recreate it all at the beginning. And it seems to be, why are you training? Stop. There you go. So I like to rerun it from here, that part, set the new learning rate and compile the model, and then start it again. So maybe it was just learning too slowly, and we'll try it again with a faster learning rate at just 0.01. Whoa, we're doing worse. Why are we doing worse? That's not good. Let me try doing the same thing, but setting the learning rate back to what it was before. So I try that again, and then we run all that stuff again. Only thing I did was just add another 0 here, making the learning rate smaller by a factor of 10. Hey, we're learning again. So what happened there is basically that you can't just say learn as fast as possible, because this is the jump that it takes to learn each. Every time it's learning, basically, it's saying how big a jump do you want to take. If you take a super big jump, it's not going to be able to figure out all the different classes, and it's going to really fit to, it's just going to start to learn the wrong patterns, basically. It's a big statistical conversation of what's going on, but the idea is that you can't just take super massive jumps and expect it to train well, because it just goes in the wrong direction and it's never going to get better. So this is something, if you've heard the term hyperparameter optimization, that's something you definitely have to optimize and just kind of figure out which is the best one to use. We could have seen something else, which was if we had a learning rate that was like this, a very small value, and we will just run that from the beginning again, and we run our model. Okay, so we let that go, and what we'll see this time is that the accuracy will get better. I guarantee you it will get better with every single epoch for a very long time. but it's training very, very slowly. You want to increase the jump, you want to make a bigger learning rate, and something in the middle there where it's not so high, or it's not such a big jump that it can't figure out, but it's also not such a slow jump that it's just learning slowly. And a really good one to try at first is 0.001, and it turns out that that was the correct one. For different problems and for values of different magnitude, basically, if you're dealing with California housing, you may want a bigger learning rate, possibly because the values are bigger, maybe smaller. It depends what you're dealing with, basically. Okay, so that's the basics of training a neural network, and we can do it. We can make a different model, a convolutional neural network, by doing something like this. So we're going to copy most of this stuff. We're going to copy this. We're going to put it down here, and we'll make a convolutional neural network. Well, this is 28 by 28. Well, that's fine. So convolutional nets are fine at taking pictures, but it does need to do something where well, it depends if you're doing transfer learning. So if you're doing something called transfer learning, which basically takes a model that's well known, like something like MobileNet or Exception, or some of the more common models, they are used to taking RGB images. So you kind of have to convert your 28 by 28 grayscale image to a 28 by 28 by 3 RGB image. Basically how you would do that is you would actually just really, well, the safest way to do it is just to look at this TensorFlow function, which takes, let me look at it, is TensorFlow grayscale to RGB. So you could really just, you could work on calling this function. That's an option, we could do that, but we're not going to do something called transfer learning today, which is generally better. You generally want to do that if you can. But to make our default convolutional neural network from scratch, we don't actually need to do that. We can actually just take the input, which is 28 by 28, and then we can do something called a reshape. So same as reshape as we saw before, we'll actually do that instead of doing a flatten. So we'll add a reshape where we make it the shape that we want, which is 28 by 28 by 1. That's a safe reshape because it's really just, it looks a little bit different, but it's exactly the same thing really. Why did we add this third dimension here? It's because convolutional neural networks want to take pictures, and so this value is either generally 1 or 3, 3 for RGB or 1 for grayscale. We are going to forget about this for now. We're going to have the same output, so we're actually totally happy with this output. Now what we're going to do is model.add layers.conv2D. So generally when we say convolutional neural network, we mean two-dimensional. And why is it 2 dimensions? It's because it's sliding this 2D window across. It's sliding across like this. It's also sliding it across like this because it goes like boom, 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 boom. Moves it across 2-dimensional. That's why it's 2D. There's also 1D and 3D as well. So conv2D, we can add maybe 32. We'll see what the shape of this thing is. I don't want to describe too much about what this is. The summary is going to explain it a lot better. If we were to do activation, sorry, it's hard to see what I'm typing there. We do ReLU as well in here as well. So this is going to convert it not to 32. Actually, we need to specify this other thing, which is basically the filter size. So we'll do a 3 by 3, and we'll do an activation is equal to, all right, kernel size is actually the right word. So we have 32 filters is the term, or 32 of these different windows that we're going to slide across. We slide each of these 32 windows across all of these different spots. And they're going to be 3 by 3. We specified that it was 3 by 3. So we have 32 different times we're going to slide this window. I'm explaining it slightly not how I want to be. We have 32 different windows, and for each of those windows, we're going to slide it across each of the different spots here, if that makes sense. I'm not going to explain it any further than that. I want to show the shape that results from this. We do conv2D 32 by 3 by 3, and then generally what is associated and comes after these convolution layers is something called an average pooling 2D. And it's very, very similar, except this does not learn anything. This is the part where it's actually learning stuff. And average pooling 2D simply just goes in and it takes a window like this and it just replaces it with the average value. So it's going to very dramatically shrink the dimensions of this image because it's just going to take a big window, and we specify the window here. We specify that with, we'll say, 3 by 3. And so that's going to slide this window across and do an average. And actually 3 by 3 seems a little bit big given that we're only dealing with 28 by 28. So we'll do a 2 by 2 like that. And then we will just actually flatten this. So model.add with a flat layers.flatten. Okay, and then we'll see if that works. Okay, there we go. So it takes in a 28 by 28. It converts it to 28 by 28 by 1. Convolutions, sliding a window across. Now instead of just this one channel here, you can think this this is like just the values of just one image here. And then what we do is this converts it to 32 because we slid 32 different windows across from it. Now we basically have 32 different images. Kind of weird concept, but it's good. And it does shrink the dimensions a little bit. That's because it's this 3 by 3 window we're sliding across with this convolution thing. It's going to shrink the size of each of the image, but we're going to make 32 images out of it. We do an average pooling, which will dramatically decrease the size, which goes down to 13 by 13 by 32. But you can see there's no parameters here. We're not learning anything from this. This is where we learn stuff. We learn these 320 parameters. Okay, and flatten, we do a flatten to decrease the dimensionality, which just not decrease it, but reshape the dimensionality to convert this from these basically multiple pictures here, where we have 32 13 by 13 pictures, and then we just stretch all that out into a long vector to get 5408, and then we get a dense to get that same activation as we saw before. And then we will do we will just fit the model like we did previously. I don't think it will look any different. We should be able to copy model.fit, and so model.fit xtrain, ytrain, epochs is 20, validation data is like that. I think that should work. You must compile your model. Right, thank you, I forgot about that. We should just be able to copy the compile model. It won't look any different. Model.compile, sparse categorical cross entropy should be right. Metrics accuracy, let's fit that model. And here you go, it is learning again. So this is a different type of model that is generally used for pictures. We had a big picture-like discussion in here because these are the types of models that are generally used for pictures as well as videos, because videos are just multiple pictures. And we can see here it is it's doing a little bit better than our dense model was, at least on the training set. We'll see if that applies to the validation or test set as well. Val accuracy was actually even better, 97.7%. And so it's easy to make a simple convolutional neural network that's able to solve this MNIST problem of classifying what these digits are. I think I'm going to conclude that tutorial there. There's other models that you can look at, like k-nearest neighbors from scikit-learn, boosting models from scikit-learn, and it's really, really easy. You really just import, you would just kind of import this same thing like this, except import a different model. You'd still write it very close to like this, adjust the parameters that it has. You'd fit it with xtrain, ytrain. You'd see how well it performs. There's also different ways of outputting. Actually, I do want to, I will do that before finishing off. Accuracy is not necessarily the only thing you want to look at. In fact, there's a really pretty tool in sklearn. I think it's called classification report. I'm forgetting. Right, okay. So if we do, and I'll just stop that. I don't really care how well that model performs. It's not really the point. It would do pretty well. If we do from sklearn.metrics import classification report. Why are we importing this? It's because we are solving a multi-class classification problem, and so this is a good way to display our accuracy, our results. Classification report on, we can do, if we get, what is it? We'll just do our random forest model for fun. RF, let's get the predictions on the test set. So we do it like rf.predict right there. Okay, so this is what it predicted on the test set versus y test. I believe it complains because, right, you have to do that. You should just be able to print this, and then it will format that better. There we go. Okay, so this here, it outputs for each of our, sorry, 1 second. for each of these different classes that we have, 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, we see these things called precision, recall, F1, and support is just the amount of those examples that we had. And it turns out that for classification problems, you do want to look at these values, which are precision, recall, and F1. I don't want to explain right now about all of these different ones. It has the conversation of false positives, true positives, false negatives, true negatives. If you've heard that discussion before, that's what all of this is about. But really, you just want to optimize. You want to get the accuracy as high as possible, and you want to get the F1s on each of these as high as possible as well. It's just different metrics that you should look at when making a model. If you have not dropped a like on this for me doing that, I would really appreciate it. I hope that did help. Let me hopefully answer some questions. Make sure to ask any questions that you've had about that. I'm sure there's a lot. I did like a crazy beginner tutorial. There's a lot going on there. I do hope that was very helpful. And of course, you will probably not. I think I only had to look up like one or two things. When you're going to do this, you'll have to look up all this different syntax, and that's totally fine. That doesn't matter at all. And the order in which to do all these things, like you make the model, then you compile it, get the loss function, you get the optimizer, you fit the model, all that different stuff. If you do enough projects, then you'll get pretty used to doing that. And it never really matters if you memorize the syntax or not. Okay, hope that was beneficial. Okay. Got my Raul. I doubt you're still here after all of that. You might be. Okay. How to improve logic in Python? I don't know what that means. Okay, I'm gonna stick around for like a minute or so to see if there's any questions on that. Otherwise, I'm probably gonna get going. Okay, looks like we're good. Okay, thanks everybody for stopping by. I hope to see you again soon. Maybe on the weekend, maybe tomorrow. I'm not sure. It depends how I'm feeling, really. I don't like to plan too much because if I'm not feeling it, then or if I get busy, then I don't want to abandon stuff. But yeah, thanks so much for stopping by, and I will see you again soon. Bye bye.